So have you ever wondered why none of the mathematical software nowadays, despite decades of development, can solve your mathematical reasoning problem out of the box? I'm going to show you one tool that I found that is going to give you this power. Okay, let's start. So the new tool is called Ternlang. It's a new programming language, just like Lean, MATLAB, but it runs in the web. It has a nice web browser, IDE, and the notebook systems. If you look at how we define the first ever concept in Ternlang, it will be set, and it's actually extremely easy. So we define it using a structure. Um, so in Ternlang, actually in mathematics, all we're doing is basically defining structures and then relations, and then try to prove relationship between different structures. So set is an empty construct because it does not have any component that is another math concept. So it is empty inside. And look at this square bracket. It actually means a container structure. After we have set, we can define other concepts like empty sets, union, and intersection. You can see the notation here, and we can show it in the slide mode where we can scrutinize every concept easily. And if there's only one thing you want to take away from this video, it's that mathematical proof is really easy. It's after developing this kernel of these programming languages. So the only thing that's stopping us from getting to know math better is the way the definitions are created. Is to manage the definitions, the structures, and the relationships, and how to reduce them. And that's the hard part. But the logical part of a proposition is extremely easy, which is just we start. So the process of proof is that we start with a proposition, and we constantly apply rules that's proven to be correct, like a theorem, like axioms, and so that we can rewrite the original proposition into something simpler or something that's more useful. And after that, as long as we reach a axiom, so we are going to transform the original proposition into something that looks exactly like a axiom. And that's where we mark a complete on the proof, where the QED stands for. The end of the proof is extremely easy, and the only thing you need to do is to manage the structures and definition well, which is what Ternlangs have done a very good job in. Yeah, so this is how we do it. So this is how the proof block look like in Ternlang. So unlike Lean, where it only shows one proof state at a time, Ternlang shows multiple proof state, and it shows the steps by which we progress the proof in one place. And it is interactable between the editor and the proof panel, so that you know exactly what happens per tactics. And this is very handy. And let's look at a very simple proof. This one is basically the first proof in set theory, very easy, but actually it takes some careful calibration. So the tactics is also very familiar as in most proof assistant, but it is more targeted. So you can see exactly what's going on. Yeah, so after this splitting of the concepts, we tackle conjunctions in the proposition. So if you have two statements to be true at the same time, you need to tackle them. You need to prove them separately. So only when they are both proven it is proven. Yeah, so this is how we solve a proof. And there's much more proof here. And I will share a link down below so that you can experience this for yourself. Please open it in the browser in Chrome. That'll give you a best experience. And please follow along. Please subscribe if you want to see more these videos before. We are going to continue translating the whole book of abstract algebras. So please follow along and leave your question in the comments. So we'll probably answer in the next videos. Okay, so see you guys.